You hear it all the time, right? AIs with billions or even trillions of parameters. But have you ever really stopped to think about how we train these things? I mean, these are massive digital minds. So today, we're going to dive into a new paper that's come up with a really clever shortcut, a way to teach these giants without, completely breaking the bank or the internet.
And that's the big question, isn't it? It's one thing to build an AI that has more connections than a human brain, but it's another thing entirely to actually teach it anything. The methods we've been using, well, they're starting to buckle under the sheer weight of this challenge. The scale is it's almost unimaginable.
So here's the fundamental problem we're facing. Our ambition to build bigger, smarter AI is just racing ahead of our ability to actually train them. We're creating these incredible digital titans, but the cost, and I mean cost in time, in energy, in pure raw computing power, is becoming a massive bottleneck. It's a wall that could seriously stall the entire field. Okay, so to really get why this new shortcut is such a big deal, we first need to take a quick look at the old way of doing things. And for inspiration, researchers have often turned to the most powerful problem solver we know, nature itself. It's a concept called evolution strategies, or ES for short. Think of it like this. You create a whole population of slightly different AI models. You throw a task at them, see which ones do it best, and then you create the next generation based on those winners. It is literally AI survival of the fittest. And look, this evolutionary approach is wildly powerful. It really shines in those messy real-world situations where there's no clear, perfect instruction manual. Instead of needing a perfect roadmap, the AI can kind of feel its way towards the best solution, even when things are noisy and uncertain. It sounds pretty great, right? Almost perfect. But there is a massive catch. What happens when you try to apply this brilliant evolutionary idea to a model with not just thousands, but billions of parameters?
Well, the whole process just collapses under its own weight. The standard, or what the paper calls the naive version of this strategy, becomes, and I mean this quite literally, prohibitively expensive. The amount of data you have to track for every single member of your AI population is staggering. The whole system just grinds to a halt.
And here's the math behind why it breaks down. For every single layer in the network, the cost scales with m times n. So think of m as the number of inputs of that layer and n as the number of outputs. When you've got billions of parameters, those numbers are just enormous. Multiplying them together, well, it creates a computational and an economic nightmare.
But what if there was a shortcut? A way to get all the amazing benefits of evolution, but without that crushing, insane cost. Well, that's where this breakthrough comes in.
So, meet the hero of our story, a very cleverly named algorithm called EGGROLL. Yeah, it's a bit of a mouthful. It stands for Evolution-Guided General Optimization via Low-Rank Learning. But the idea at its core is just brilliant, and it's designed to solve this exact scaling problem.
Here's the best way to think about it, using a great analogy. Imagine you're trying to recreate a masterpiece, a famous painting, by placing millions and millions of tiny individual dots. That's the old way. EGGROLL is like suddenly realizing you can get an almost perfect copy using just a few really clever broad brushstrokes. That's what this low-rank approach is. It's a genius simplification.
And the difference this makes, it is dramatic. Just look at this. The old method's cost was tied to m times n. EGGROLL changes that multiplication sign to a plus sign. Its cost is tied to m plus n. When you're dealing with numbers in the billions, changing a multiplication to an addition is, well, it's a total game changer. The improvement in efficiency is just incredible.
And the magic is all in that little letter R. That R represents the number of those broad brushstrokes. And the whole trick is that R can be kept incredibly small, way, way smaller than the actual size of the model. That's where the astronomical savings in memory and computation come from. Okay, so a shortcut sounds great, but a shortcut is only useful if it actually takes you to the right destination, right? So the big question is, does this incredibly efficient method actually produce good results?
Well, first off, the math checks out, and that's a big deal. The researchers proved that EGGROLL's broad brushstroke updates get you to pretty much the exact same place as the slow dot-by-dot method, and they get you there much, much faster. So this isn't just a guess, it's mathematically sound.
And then, the real-world experiments confirmed it. They totally nailed it. First, it matched the performance of the old slow method in complex learning tasks, but was way faster. Second, it proved to be a really competitive way to improve the reasoning abilities of large language models. And third, and this is super cool, it actually unlocked the ability to train entirely new kinds of AI that were just too unstable to work on before.
So let's zoom out for a second. What's the real payoff here? Why does a more efficient algorithm matter so much for the future of artificial intelligence?
Because this is about so much more than just saving time or money. This is about making the impossible possible. By completely shattering that computational barrier, EGGROLL is basically giving researchers a license to explore all these radical new ideas that were just way too expensive to even try before.
I mean, just think about what this unlocks. We can now explore training these massive, hyperscale models using evolution, without even relying on traditional methods like backpropagation. We can make today's LLMs better at reasoning, more efficiently. And we can start building entirely new AI architectures we could only dream about before. And here is a fantastic, specific example right from the paper. It allowed them to build language models that work only with whole numbers, integers, no decimals, no fractions. This is a completely novel type of architecture that could lead to radically more efficient AI. And it was only made possible because of this new training method.
And that really is the big takeaway here. Breakthroughs like EGGROLL aren't just small incremental improvements. They are fundamental tools that remove the limits on our creativity and our ambition. And that leaves me, and hopefully you, with one very exciting, very open question to think about.